Alrighty then. Today's exciting radical lecture is about dividing. So we've done square roots and we've simplified square roots. We've had square roots where we've used fraction numerators. All right. When we are dividing and simplifying radicals, the whole key to success is no square roots are allowed in the denominator. No square roots are allowed in the denominator. We think maybe someday in the near future that's going to change because some math teachers think, well, maybe we don't have to do this. However, the ACT test still does it and most colleges still does it, so we'll still teach you this. So, I'm going to do a whole bunch of ways to show you how to not get a square root in the denominator. And the first example is this square root, the square root of 16 over 25. All right. Well, you are allowed to put one big square root if you'd like, or to keep them as such. Well, on this particular example, you look at the square root of 16 and you get a smile on your face because you just know that answer is, and you see the square root of 25 and you just know it's going to be. Do I have any square roots in the denominator? Does 4/5 reduce any? If they were all this quick, you'd be done with your homework in a minute. That is the simplified version of this. All right, we're going to get to slightly different. I'm going to have the square root of 21 over the square root of 12. And I'm going to show you two good ways to go about this. Two good ways to go about this. One good way is to try to make smaller numbers, because smaller numbers is easier mathematics. So what you could do, this is one of the ways to do it, is make one big fraction, 21 over 12. All right, is there any reducibility that goes on in this? Does 3 go into both of them? Yes, say yes. Yes, I mean, they can hear you on that. Does that become 7 over 4? Yeah. All right. I divided 3 out of here. I divided 3 out of here. And I got 7 over 4. And you can go from one fraction to two fractions, one fraction to two fractions. Cool. Say, we are not concerned about square roots on top, but the square root on bottom. And that's a cool way to do it. So if you notice, the two numbers under the square roots could reduce to smaller numbers. Please consider doing that. Please consider reducing them to smaller numbers. That's a good way to do it. Another good way to do it, this is just going to be a medium way to do it, is this. Say, well, I got to get rid of that square root of 12, and I know how I can do it. I can multiply it by the square root of 12 over the square root of 12. What is the square root of 12 over the square root of 12? It's worth 1. Could you go to Super America and say, give me change for a square root of 12 or a square root of 12? And they would give you 4/4. They would. They do that. Well, here I get the square root of 21 times 12. I don't know. That is 2, 4, 0, 1, 2, 252. All right, we've got our calculators handy. Does 4 go into 252? 252 divided by 4. I've heard a yes. Let's go up. Does 9 go into 252?
Yeah.
Okay, here, let's do a little math trick. If 4 goes into it, if 9 goes into it, what's 4 times 9? 36. Probably 36 goes into it. See if 36 goes into it. How many times? 7 times. 7 times. So this becomes square root of 36 times 7 over 12. Does regular 6 over regular 12 become 1/2? 6 over 12, 1/2? Is that the answer I had a few minutes ago? I think it was. We could go back to the recording and see. All right. Well, hi. Well, those were pretty big numbers. And you folks here, as we're approaching the end of April, those are pretty big numbers. Smaller numbers are more fun. Mathematically, smaller numbers are more fun. So let me show you one more way that you could go about this. You could look here at this square root of 12 and say, hey, that is the square root of 4 times the square root of 3, which is now what we could do is take that times the square root of 3 over square root of 3, because that also equals 1. Underneath times underneath. 2 square root of 3 times square root of 3 is 3. 63 breaks into 9 and 7. 3 over 6 becomes 1/2. They all get to the same answer. Did the quickest way seem to be to take this 21 over 12 and make it small right to start? Yeah, I would say if you could make the fraction anything smaller by reducing it, that's the quickest way. The next quickest way is if you can break that denominator into something smaller, do it, because you got smaller numbers. Or if you want to take it times root 12 over root 12, you sure can. All right, those were algebra 2. Let's get to algebra 2 plus, and then we'll get to algebra 3 eventually. All right. Square root on the bottom, not allowed. Don't write this down because I'm going to do something wrong. I'm going to do something wrong. No, I'm going to do something not helpful. I'm going to do something not helpful. Not wrong, not helpful. Don't write this down. I'm going to take this times the square root of 3 over square root of 3. That's correct. I mean, that's correct. Nothing wrong with that, but it's not helpful. Because I'm going to take square root of 5 times square root of 3 and I get square root of 15. No big deal. Distributive property. Square root of 3 times negative 1. Square root of 3 times square root of 3 is square root of 9, which is 3. That's correct. But did we get anywhere in my rule of no square roots in the denominator? Do we still have one? There's nothing wrong with that. It just didn't help. It just didn't help. It just didn't help. So what we do is we look at the denominator and we simply change the middle from the minus to plus or plus to minus. So what we do is the following, because it's pretty cool. We take this times negative 1 plus square root of 3. We simply change the middle. That is funny. Okay, good. I'm glad people are in good moods. All right. The numerator. Distributive property. Root 5 times negative 1. Root 3 times root 5 is root 15. Okay, this is so cool. We're going to do FOIL. First, outside, inside, last. Negative 1 times negative 1 is 1. Outside, negative 1 times root 3 is negative root 3. And all of a sudden, I am discouraged. This does not look good. Now I'm going to do the inside. Negative times negative is positive root 3. And negative times positive is negative root 9, which is negative 3. First, outside, inside, last. Oh my goodness. Please say no. Can these top two add together? Can you add a root 5 and root 15? No. But look at this. Those two right there, subtract away. They're gone. 1 minus 3. Voila. Oh, that worked well. That worked well. Do I need to make another recording yet? Do you know how long you've been bored with this? 10 minutes and 52 seconds. Fun. Oh, the joy in your faces. That's why I went into teaching. Yep. Just to look at your faces and the joy. Wow, this is amazing. Oh, all right. You people are in good moods. Good for you. Do we still do May Day celebrations? By putting little baskets on someone's house, knocking on the door and running away?
It's not May Day yet, it's April.
Yeah, no, we're just planning for it. Do any math teachers get upset with that root 3 being in the numerator? No. Do any math teachers get upset with that root 5 in the denominator? We do. You look at the denominator because that's where the trouble is. You make that minus into a plus and you write negative 1, it's the middle, plus 2 root 5. You have to do the same thing on top. Now this is going to be a massively stinky foiling, first, outside, inside, last. First, negative 4 times negative 1. Well, that's not stinky. NS, not stinky. Negative 4 times 2 root 5. So the 4 and 2 multiply. Negative 8 root 5. The inside, 1, negative 1 times root 3. And the last, 2 root 15, and it is plus plus. Well, that's messy. However, math teachers don't care if it's messy on top. FOIL first. Negative 1 times negative 1. Outside, negative times positive, negative 2 root 5. Inside, negative times negative is plus 2 root 5. And the last, negative times positive is negative. The 2 times 2 multiply to be a 4. The root 5 times root 5 is root 25, which is 5, so it's really 4 times 5. And watch what happens. Nothing good happens on top. But on bottom, they subtract away, and you get negative 19. And